Good morning, everyone. Welcome to the class of C333 Environmental Engineering 2. So, in our last class, we discussed the sewage treatment, different sewage treatment options, right? And then we discussed these things. Am I right?
Yes, sir.
And then we discussed the microbiology of sewage, and then we discussed the bacterial growth pattern. Now today we'll discuss from here, that's biochemical oxygen demand. So by now we know what is biochemical oxygen demand. So the definition, if you look at this, BOD of a sewage or wastewater may be defined as the amount of oxygen required by the microorganisms in utilization and ultimate destruction of organic matters present in the sewage in a specific time and at a specific temperature, usually 5 days and 20 degrees Celsius. We will discuss further on this. Why 5 days? Okay. So basically, although BOD is a measure of oxygen demand, but what does it represent, guys? What does it represent? It represents that in a water sample, how much organic matter present. Not only organic matter, basically biodegradable organic matter present. That means which can be oxidized by microorganisms. Clear?
Yes, sir.
What does BOD represent? Biodegradable organic matter. Okay. What does turbidity represents? Presence of suspended material, right? Suspended solid, right? Am I right?
Yes, sir.
What does TDS represents? Salinity. So similarly, what does BOD represent? Biodegradable organic matter. So BOD is a measure of biologically oxidizable organic matter present in the sewage or wastewater. Hence, BOD test has enormous significance in treatment of sewage and wastewater and water pollution studies. So these are the most common applicable areas where BOD is used. It gives the quality of the natural waters, wastewaters, and effluents. It determines the pollution strength. Higher is the BOD, higher is the pollution strength. It is required to design treatment facilities. It is used in pollution and self-purification studies. It serves as a means of regulating the effluents and water pollution. Now, if we look at the BOD kinetics, for example, in a sample of water at time t equals to 0, you put some organic matter here, biodegradable organic matter. And initially, yeah, when time was 0, D was, for example, 7. And biodegradable organic matter let's say organic matter here. Organic matter was, let's say, 15. Are you following me?
Yes, sir.
Yes, sir.
Okay. Now, with time, after 1 day, 2 days, 3 days, there are microorganisms, and there are microorganisms, and these microorganisms will use this organic matter as a food, and they will continue to degrade them using this equation, like organic matter plus oxygen. Here is the microorganisms. They will oxidize it to carbon dioxide, water, plus other substances, others, plus new cell, that means new bacteria and other microorganisms. So, what is happening, guys? This oxygen is being used, and this oxygen is supplied by whom? By the dissolved oxygen. Am I right? So, with time, you will see that this organic matter is breaking down. That means this is reducing. Are you following me?
Yes,
After
sir.
1 day, bacteria has eaten, basically. The bacteria has eaten the organic matter or consumed the organic matter. So, this may be like 11. And DO, what would happen with DO, guys? DO will increase or decrease? DO will increase or decrease? With
Sir,
this
increase.
with this reaction, oxygen is being consumed. Oxygen is being consumed. So as this reaction continue to happen, what would happen with the DO? Tell me.
Decrease, sir.
Huh?
Decrease, sir.
Decrease. So DO will be also decreased. Like this will be 5. With further time, it may be 9, it will be 4, it might be what? Say any value, right? 6, it might be 2. Okay, let's call this 3. Are you following me?
Yes,
Yes,
sir.
sir.
Now,
Yes, sir.
if you put these values here, time, here time, and here the let's organic matter, let's call it DAT, L. This is the L basically. L means the organic matter present. L, organic matter present. So initially it was 15. So with time it will get reduced. Like when it was 0, this is 15. When this is 1, this is 11. Right? 11. When this is 2, this is 9. Are you following me?
Yes,
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 sir.
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 When this is 3, this may be 6. 3, this is 6. So the curve will be like this. Now, if I tell you after 3 days, or after, let's say after 5 days, 4, you have a value, 5, you have a value. After 5 days, let's say like this. Here, this is the 5. Okay.
Sir, elder की organic matter. Sir,
Yes.
what is it, sir?
Yes. So after 5 days, if I tell you how much oxygen is consumed, or after 3 days, how much oxygen is consumed, what did you tell? 7 minus 2. Am I right? 2 is remaining, guys. 2 is remaining. 7 was initial. So how much has been consumed? 7 minus 2. This is consumed. Huh? Okay,
5.
so consumed DO. This is 5. Clear?
Yes, sir.
Okay. Now, if we take this dl by t dt, that means consumption of organic matter with time is proportional to the organic matter present at that time. That means at any point, for example, at time 1, at time 2, or at time 3, any point, for example, at time 2, the rate dl, this is dl, and this is dt. This is proportional to the amount of L remaining at that time. Did I make it clear?
Yes, sir.
At this point, any point at this point, this dl by dt is proportional to the L remaining at that particular time. This point, this time, this L. Okay, so you can make it equal by using a constant, and dl by dt is proportional to L. So we can write dl by dt equals to minus k into L. Why minus? Because with time this is decreasing. With time this is decreasing. That's why we provided a negative sign here. Okay. Now you can write dl by L equals to minus k dt. So if you integrate this, okay, if you integrate this 1 by x dx, the ln L from initially, what was your value, guys? The highest value. That is, let's say this is L0. Let's say this is L0. Are you following me?
Yes,
Yes,
sir.
sir. Yes, sir.
Let's say this is L0. So from L0 to LT. What is LT? At any time. L is LT is L is at any time. Okay, it can be at 3, it can be at 2. Okay, equals to for time 0 to t. When time t equals to 0, L equals to what, guys? L0. When time t equals to t, L equals to LT. Clear? So L0 to LT, L0 to LT, 0 to t, 0 to t. Clear?
Yes, sir.
So if you integrate this constant t, 0 to t, you'll get this. You'll get this. Okay. Now, from here you can write log. This is log E base log. It came from the integration. Now you can always convert it to 10 base log. So if you convert it to 10 base log, then your k constant will be changed to k1, and the relationship will be k1 equals to k divided by 2.3026. Why this value? Because you are converting E base log to 10 base log. Okay, you can check this. This is the formula to convert Like from, if you convert from kg to gram, how much you need to multiply with? 1000, am I right?
Yes, sir.
Similarly, if you want to convert from e base log to 10 base log, you have to divide it by 2.3026. Anyway, so you just rearrange it, and eventually you will get this, that lt equals to l into 10 to the power minus k1 into t. You'll get this, lt equals to l 0 into 10 to the power minus k1 into t. Clear?
Yes, sir.
Okay. Now, tell me what is LT? LT is BOD remaining at any time t. So you take any time here, for example, t, for any time. What is the L corresponding to that point? This is LT. At any time t corresponding L is LT. Am I right? So this is
Ji,
what?
sir.
This is what? This is remaining. This is remaining. That means at time 2, what is the BOD remaining? The L remaining 9. What is at time 3 days? What is L remaining? 6. So remember, this is remaining. Okay. Now, when we test a BOD, we perform a BOD test here, like this. Let's do it again. At time t, this is DO, this is BOD, or we may call it L, and this is yeah. Let's not call this BOD. Let's call it L. At this point, let's call it L. Okay, L remaining, organic matter present remaining. Here also, let's not call this BOD. Let's call this organic matter L. Okay, L remaining, L remaining. At time t equals to 0, let's make this constant 7532. So 75320 1 2 3, and then 15 11 9 6. So 15 11 9 6. Now 1 2 3 4 5. Let's say this is 1.5. This is 4 3. Now uh, this graph, if you look at this graph, usually it goes like this. Can you see it clearly, guys?
Yes,
Yes,
sir.
sir. Yes, sir.
Yes, sir.
Now this continues to happen for a long time, but you can see that it has almost reached to finished point, right? Here, it has almost reached to finished point. Am I right? Did you see this?
Yes, sir.
Yes, sir.
Almost 90% has been consumed by this time. 95% has consumed. Okay, this is T. So this is actually by experiment we see, and by now we know that after 5 days, T in days, okay, after 5 days, almost 95% BOD is consumed. I mean, whatever you can consume, this is consumed by 95 by 5 days. Okay, it may happen like this also, by the way, like this. Okay, so if we look at this now, this is L and this is time T in days. I have 1, 2, 3, 4, 5. So you took a sample where it has 15, it had 15 L at time t equals to 0, and this should be around to like this value should be around 11, 6, 3, 1.5, 0.3 for example. Now if I tell you guys that at time t equal to 0, what was the organic matter present in this sample? What did you say?
15.
15, right? You need to know the 15. Fine. Now, you started from here at time t equals to 0, where it was around 15. Here is 15. You need to know these, guys. You need to know this. Okay? So after a particular amount of time, let's say after 5 days, what do you want to know? You want to know what is consumed. Am I right? You want to know what is consumed. It's YT. This is actually approximately, what is this value? 0.3. So 15 minus 0.3, almost 14.7. 14.7 or approximately 15. Am I right?
Yes, sir.
And this is your LT. This is your LT. This green color. This is one is LT. Now, what do you need to know? LT or YT? LT
YT,
or
sir.
YT? YT. So what is YT, guys? YT equals to, this is your L0. So YT is L0 minus LT. Am I right? YT equals to L0 minus YT. Let's come to this point. This is also YT. This is also YT at time t equals to 1, 2. At time t equals 2. This is YT at time t equals to 5 days. So YT at this YT is what? This YT equals to L0 minus LT. Am I right?
Yes, sir.
Again, YT equals to L0 minus L. T, then you will get this. If you subtract these from these, you will get this. So YT equals to L0 minus LT. Is it clear?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
So now you put this value Yt equals to, okay, write it down here. You can write Yt equals to L0 minus, put the value of LT here, okay, L0 10 to the power minus K1 into T. If you take this L0 as a common, 1 minus 10 to the power minus K1 into T. So YT. Now, this is basically the BOD. This is basically the BOD. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, if you take this value YT at 2 days, it will be BOD 2, or YT 2. If you take this value at 5 days, it will be BOD 5 or YT 5. Okay. Now, usually we take it at 5 days. Why? Because after 5 days, usually 95% is consumed. Then you will get this 14.7 approximate value of 15. Actually, we need this value. How much organic matter was present? If you take this at 2 days, this LT may be 6. So YT will be what, guys? 15 minus 6. Am I right? 9. So this is 9, but this is 15. What do you want? You need to know this. Am I right? Initially, how much was present? That's what you need to know. Am I right?
Yes, sir.
So taking it less than 5 days may not give you the actual, or at least the value which is close to the real value. Taking it at least 5 days will give you the actual value. So we take BOD at what days? 5 days. Okay. And what is the formula? The formula is this. Now, through the process of experiment, you can calculate the value of K1, and this is the formula. K1 equals to K20 theta to the power T minus 20. Now, what is K1T and K20? As you know that these bacteria, the efficiency of these bacteria or microorganism is temperature dependent. That means um, they usually have a optimum temperature like 25 to 30 degrees Celsius or 20 to 30 degrees Celsius. Okay. And if you increase the temperature within this optimum range, their efficiency usually increased. Their efficiency gets increased with higher temperature up to a certain value, of course. So this K value also gets changed with temperature. This K value also gets changed with temperature. Therefore, in lab, we do this test at 20 degrees Celsius. Clear? So that we can maintain a standard value. We can maintain a standard value. Otherwise, everyone will do at different temperature, and BOD value will be different for each person. So to make it uniform, we use a constant temperature, 20 degrees Celsius. Did I make it clear?
Yes, sir.
Now, if this reaction or this microorganism are working at a temperature different than 20 degrees Celsius, that means 21, 22, or 23, then your K1 value will get changed. How it will get changed? This is the formula. Like K1 at 20 degrees Celsius. This is the standard. But if you take any value that is not 20 degrees Celsius, like any value T, this T can be 21, 19, 18, 23, but not 20. Then it will change according to this formula. Like K1T will be K120 into theta to the power T minus 20. Are you following me?
Yes,
Yes,
sir.
sir.
This theta value usually ranges between 1.082 to 1.087 degrees Celsius, 7 in different temperatures for 10 degrees Celsius and 30 degrees Celsius. It varies. Let's say this is 1.083. The value of theta equals to 1.083. Now, if I tell you, okay, guys, K1 at 20 degrees Celsius is 0.13 per day. Unit is per day. Then what will be the value of K1 at 22 degrees Celsius? You can calculate this from this equation. K1 at 22 degrees Celsius is equals to K1 at 20. What is this value, guys? What is this value? For you now, what is the value? What's the value? Hello?
So
Can you
0.13.
0.13 multiplied by what is the value of theta? 1.083 to the power T minus 20. What is your T, guys, here?
20.
22.
22, sir. 22.
Huh? What is the
22, sir.
22? 22
Sir.
minus 20. So you just calculate the value. So you can see any temperature which is higher than 20, that will increase this value, and eventually that will increase this number. Why? Because as I told you, that as the temperature increases, the efficiency of that means the activity of the microorganisms increases. That means the K value also gets increased. K value increase means rate is higher. BOD reaction rate is higher. Okay, the microorganisms are degrading the organic matters at a faster rate. K higher means reaction faster. Clear?
Yes, sir.
So you have to remember that this LT is the BOD remaining, and this is the BOD consumed. This LT is BOD remaining, but we do not want to know the remaining. Usually we want to know the BOD consumed. And if you want to know this value, you have to perform this test until continue the test until how many days, guys? If you want to know this ultimate beauty, how many days you have to continue this
So
test?
5 days.
5 days. Okay. So I hope that makes it clear by now. Fine. So let's see some of the examples here. The 5-day 20 degrees Celsius BOD of a sewage is 200 milligram per liter. 5 day 20 degrees Celsius BOD of a sewage is 200 milligram per liter. So it's given actually. BOD 5 or Y 5. Anything. BOD 5 or Y 5 is given, that is 200 milligram per liter. K1 is given. Since this is 20 degrees Celsius BOD and they have not mentioned anything, any temperature, that means you can assume this is 20 degrees Celsius also. So what's the formula? The formula is this: Yt equals to L0 1 minus 10 to the power minus K1 into T. You know, they are referring Yt as Lt here. Clear, guys?
Yes, sir.
They are referring Yt as Lt here. This should be, you know, Yt. Okay, let's correct it. Yt equals to L0. They are referring L0 as L here. So let's write this L0. 1 minus 10 to the power minus K1 T. So you know this value, by the way. BOD 5 is given. This is 200. This value is given. This value is given. What's the value? 200. This is L0. 1 minus 10 to the power minus K1. What is the K1 value? 0.17 is given. And this is 5-day BOD test. Look, this is 5-day BOD test. So what will be the value of T, guys?
5 days, sir.
5 days. If this is Y2, then what will be the value of T? 2. Clear?
Yes, sir.
Like Yt2, T is 2. Yt5, T is 5. Okay? So from this equation, find the ultimate BOD, L0. L0, ultimate BOD. So everything is known in this equation. You just calculate the value of L0. Clear?
Yes, sir.
Another problem. The 5-day BOD of a sewage is 276 milligram per liter. So let's write this. First two. Fine. So what they're asking, 5-day BOD of a sewage is 276 milligram per liter. So this is Y5, which is equals to 276 milligram per liter. Fine. The ultimate BOD is given 380 milligram per liter. That means L0. L0 is what? 380 milligram per liter. Given. Calculate the BOD reaction rate constant K1. That means this. So this is Y5. What is the value of T, guys? Yeah.
5.
Huh? 5. So 276 equals to 380. 1 minus 10 to the power minus K1 into 5. So only unknown is K1 here. You just calculate the value of K1. Clear? Calculate this, please. Bring out your calculator and calculate this. Tell me the value if it matches with this one. Okay? Tell me the value, please. Okay, calculate this value. So another problem, example 3. A sample of sewage was incubated for 2 days. Incubation, that means you have cultured it. And the BOD of the sample was observed to be 165 ppm. ppm means milligram per liter. ppm means milligram per liter. So here this is basically why. How many days, guys? 2 days. Why 2 days? 165. Y2 equals to 165 milligram per liter. Are you following me?
Yes, sir.
Yes, sir.
Yes, sir.
Determine the 5-day 20 degrees Celsius VOD. So they are asking to calculate 5 days 20 degrees Celsius. Everything is 20 degrees Celsius. 5-day 20 degrees Celsius VOD. And 10-day 20 degrees Celsius VOD. Assume K1 equals to this. So K1 is given. This is also at 20 degrees Celsius, 0.1 per day. This is at 20 degrees Celsius. 20 degrees Celsius. So first of all, here from this equation, you need to calculate the ultimate VOD. Okay? You need to calculate the ultimate VOD minus K1 into what will be the value of T, guys, here?
2.
2. So here 165 equals to L0, 1 minus 10 to the power minus K1 is given. K1 is actually 0.1 into 2. The only unknown is L0 here. Tell me the value, please. The value of L0. Tell me the value, please. This will be 447 milligram per liter. Check it, okay? With your calculator, check it, please. Now,
Ji, sir.
you have it matches, right?
Yes, sir.
Okay, now
Yes, sir.
you have this formula y5 equals to L0 1 minus 10 to the power minus K1 into 5. Now y5 L0, you know this value 447. 447. You have just calculated this. 447. 1 minus 10 to the power minus K1 is 0.1. So 0.1 into 5. Now, easy, calculate y5. What's the value? Clear? Tell me the
Yes,
value,
sir.
please.
Yes, sir.
305.
305.64.
30 approximately 6 milligram per liter. 306. Similarly, you calculate the value of y10. Just put the value 10 here. You'll be able to calculate y10. That will be 402 milligram per liter. Clear?
Yes, sir.
Yes, sir.
Now remember here, the value of K1 is given uh, at 20 degrees Celsius. If I had not given it at 20 degrees Celsius, like K1, the value of K1 was given at anything like 25 degrees Celsius, then what would you do? You have to calculate the value of K1 at 20 degrees Celsius. Why? Because these values are given at 20 degrees Celsius. Look, BOD at 20 degrees Celsius. BOD at 20 degrees Celsius. BOD at 20 degrees Celsius. That's why your K1 will also has to be in 20 degrees Celsius. Now, if I give you the value at 25 degrees Celsius, then you use this equation to calculate the value of K20, K120. You know this, right? You know this, you know this, you know this. So you calculate this. Clear?
Yes, sir.
So these are important equations. You need to know this. Chemical oxygen demand. We already know what is chemical oxygen demand. Chemical oxygen demand is what? COD. With BOD, we only calculate the biodegradable organic matter. But organic matter can be both biodegradable and non-biodegradable. So this is the total organic matter. So how do you calculate this? The portion which is not biodegradable and as well as also the biodegradable both can be oxidized by chemicals, by using chemicals. Clear? Strong oxidizing agent like potassium permanganate, potassium dichromate. Clear?
Yes, sir.
So if you can oxidize them all, almost all by chemical oxidizing agent, then you can calculate total of organic matter, and that is called COD. So COD represents both biodegradable organic matter and non-biodegradable organic matter. But BOD only represents biodegradable organic matter. So you can also write COD is equals to BOD plus non-biodegradable organic matter. Clear?
Yes, sir.
So that's it. That's if you have any questions, guys? No questions.
No,
Okay,
sir.
that's the end of the lecture. Thank you very much. Have a good one and stay safe.
Sir,